Bismillahirrahmanirrahim. In chapter 6 fluid mechanics, today we are going to do numerical number 5, the statement of which is a hose lying on the ground has water coming out of it at a speed of 5.4 meter per second. You lift the nozzle of the hose to a height of 1.3 meter above the ground. At what speed does the water now come out of the nozzle? Basically, the situation given to us is a pipe is lying on the ground and the speed with which the water is coming out of it is 5.4 meter per second. Now, the pipe has been lifted to a height of 1.3 meter. We have to find the speed with which the water is coming out from the pipe now. So, the given data is speed of water from hose is equals to V1, it is 5.4 meter per second, it is given to us. Height, initially the height is 0, so H1 will be 0, and finally the height will be H2, which is 1.3 meters. We have to find the speed of water at height H, that is V2, for which we will use the formula. Basically, we will apply Bernoulli's equation. P1 minus P2 is equals to half rho V2 square minus V1 square plus rho G H2 minus H1. Again, in this formula, in the solution, we will rewrite the equation. And since H2 minus H1 is equals to 1.3 meters, so we will substitute it here. As well as here P1 minus P2 is equals to 0. Why P1 minus P2 is equals to 0? Because in both cases the pressure is atmospheric pressure which is acting on the water coming out of the pipe. So the difference in the pressure will be equals to 0. We will substitute these values in equation which is called Bernoulli's equation. We will obtain the result 0 is equals to half rho V2 square minus 5.4 square plus rho 9.8 into 1.3. No need to substitute the value of rho because it will cancel out. Rearranging the equation, rho has been cancelled out and we are left with the equation half V2 square minus 5.4 square is equals to minus 9.8 into 1.3. Solving for V2 square, we will multiply 2 on other side. And in the next step we will as 5.4 square is subtracting from V2 square, when we will shift it to the right hand side it will be added in the result. So 5.4 square has been positive when we have shifted it towards the right hand side, and this equation is written as like this. Solving it, we will obtain the result of V2 square is equals to 3.68. We will take under root on both sides and we will obtain the result of V2 is equals to 1.92 meter per second. This is the velocity with which the water will come out of the pipe when it is lifted to a height of 1.3 meters from the ground. Similar to this numerical is numerical number 7, the statement of which is the speed of water in a hose increased from 1.96 meter per second to 25.5 meter per second going from a hose to the nozzle. Calculate the pressure in hose given that the absolute pressure in the nozzle is 1.01 into 10 raised by 5 Newton per meter square, assuming level and frictionless flow. We are taking basically the example of an ideal fluid, and it is given to us that the speed inside the nozzle was inside hose was 1.96 meter per second. When it is coming out of the nozzle, the speed has become 25.5 meter per second. The pressure which is acting on the water when it is about to coming from the nozzle is atmospheric pressure, that is 1.01 into 10 raised by 5 Newton per meter square. We have to calculate the pressure of water inside the hose. So firstly we will start with the given data. The given data is speed of water from the hose is equals to V1 is equals to 1.96 meter per second. Speed of water from nozzle is equals to V2 is equals to 25.5 meter per second, and the pressure in nozzle is equals to P2, that is 1.01 into 10 raised by 5 Newton per meter square. Density of water is 1000 kilogram per meter cube. Basically we have to find the pressure in hose which is represented by P1. For this, we will use the formula which is called as Bernoulli's equation. P1 minus P2 is equals to half rho V2 square minus V1 square. We have not written the H2 minus H1 part because it is negligible, height is negligible, so the factor will become 0. So in the solution, we will substitute the values in the formula. P1 minus P2 is equals to half rho V2 square minus V1 square. We will obtain the result by, after solving this, P1 will be equals to 4.24 into 10 to the power 5 pascals.